Hello, in this video we're going to go over surjective, injective and bijective function. We will also see examples of composition of two functions and the inverse function. First let's go over surjective, which is onto. So a function f from s to t is an onto function if the range, and remember what I said before about the range is the exact value, and the codomain is all possible value of outputs. When you take the function and you find an output, the exact values are range and the all possible values are codomain. For a function to be onto, the range and codomain must be exact. And one-to-one function is a function f from s to t is one-to-one, or sometimes we call it injective, if no member of t is the image under f of two distinct elements of s, which means I can have two members of the domain pointing at the same number of in the range. Bijective, which is very simple, it's an onto and one-to-one function. First, it must be function. If it is a function, then it's onto and one-to-one, therefore we call it bijective function. Let's see this example. So which relationship is one-to-one or onto? So first I have to check if it is a function. So as I said, first of all, in the function you can leave the domain like this with two arrows. So for every x there is one and only one y. So that's the first thing I check. So as you look here, right here, this is a function, good. But is this one-to-one? I would say yes, because one-to-one, all of them one-to-one, that's good. But is this onto? No, it's not an onto function. And why? Because this 2 here is by itself. So the second example here, is this a function? So again, so yes, this one is a function. Is it one-to-one? No. This is what causes it not to be one-to-one, okay? Is this an onto? Yes, nothing left by itself here, so it's an onto function. Next one here, I could see that this is a function. It is one-to-one function, 1, 1, 1, 1. And it is onto because nothing on the codomain stay by itself. So is this a function? So first I look here. Yes, it is a function. I don't have a member by itself without any arrow, and I don't have any member here leaving with two arrows. So that's why this is a function, okay? Is this one-to-one? I would say no, because of this 3 here. Pointing to A and B, A and D are pointing to 3. No, it's not a function. Is this an onto? No, 4 is by itself. No, it's not an onto. So it's a function, but not one-to-one, and it's not an onto. The next example here, is this a function? So look at this. This is break the rules. No, it's not a function. And if it's not a function, I'm not even going to talk about one-to-one or onto. So the next one here, this one here is by itself, and therefore this is not a function. This one doesn't have any output, so it's not a function. And if it's not a function, no need to talk about one-to-one and onto. Let's look at this example here. What we have is, which of the following definition describe a function from the domain to the codomain? So let's look here, and which one is one-to-one and which one is onto. So look at this one A. I go from set of integer z, like -2, -1, 0, 1, 2, and so on. There is more, just an example. And then my codomain here is n, or natural number. That means 0, 1, 2, 3. So I take -2, for example, and I square it. I get 4 plus 1, you get 5, and so on. So it's going to point to 5, and -1 square it will become 1. 1 plus 1 is 2, so it will point to 2, and so on. So is this a function? I would say yes, it's a function. And so is this a one-to-one function? I would say no, because, for example, 2 is also going to be pointing to 5, because 2 squared is 4, 4 plus 1 is 5. So right here, this is an example why it's not one-to-one. So not one-to-one. Is this onto? This is not an onto, because there is plus 1 no matter what I do. Plus 1, so 0, nothing points at the 0. So 0 right here stays by itself, and therefore it's not onto. Let's see the next example here. So I start with some set of natural numbers. That means 0, 1, 2, 3, and so on. So here just to show you. And then we get to some rational number q. So I take every member from here, from n, and I do 1 over this, and we get this. So as you see here, 0 doesn't have so it will be 1 over 0 is undefined. So we can have 1 over 0. So what can we say? This is not a function, right? Because it's not defined when x equal to 0. So if it's not a function, I don't need to talk about 1, 1 or onto. So here I will take a number integer z, and I will take also some natural number. So for example, I could take -2, 0, and the value will be a rational number, and the rational number will be -2 over 0 plus 1, which is -2 over 1, which is just -2. So this is an example. So here, is this a function? Is it defined everywhere? So it doesn't matter what I take, it will be defined. So since I take n as a natural number, so -1 plus 1 is not going to happen, because n are just negative numbers. So it's defined everywhere. And therefore, yes, it is a function. And now, since this is a function, I would say yes, because every member of the codomain is equal the range. So any number I could think of as a rational number, there is a way to get to it. So by choosing a z and an n from the integers and the natural number. So this is an onto function. But is this a one-to-one function? I would say no, because for example, -4 and 1, so that will give me z is -4 and n is 1, 1 plus 1. So this is -4 over 2, it is -2. So you see how we get to -2 by using two different coordinates from the domain. So we have two values pointing at -2. And if I can think of other numbers as well, z and n, you could get to -2 and so on. So it's not one-to-one function. Let's see the next example here. So here is very simple. All what I have, I go from a set F which has 1, 2, 3, and then the other set is P, Q, R. 2R and 1, 3. So this is the domain and this is codomain. So as you see here, this is a function and it's one-to-one and it's onto. The next example here, I'm dealing with 2 to the power of x, which means I take members, natural numbers, and for example 0, 1, 2, 3, 4, and where we do 2 to the x, which is 2 to the 0 gives me 1, 2 to the 1 gives me 2 and 4 and 8 and so on. So all powers of 2. So right here I could see that this is a function, because every member from here can have some image. So yes, it is a function, as we call it exponential function. But is it one-to-one? Yes, so I don't have any value from the domain that would point to the same value 8. Like for example 8, I don't have two values that get me to 8 or any other number. So yes, it's one-to-one. And the next question, is this an onto? So I don't have any x that I do 2 to the power of it and I get, for example, 3 or 5. So these members here stay by themselves. So this is basically all powers of 2's are range, and the other members here are part of the codomain but not part of the range, and therefore it's not onto. The next example here is that we take a function, but we take x and y from R, that's why we have R squared or R times R, and we get another order pair which is also belongs to R. So you take any real number x and any real number y, you just add 1 to it. And now the question, is this a function? Yes, because it's defined everywhere. So it's a function. And is this a one-to-one function? And yes, there is no, so it's one-to-one. Every time you add 1, you're gonna get a value for every x that is y. So this is one-to-one, and it's also an onto. Okay, so let's talk about the composition of functions. So a function f is 2x plus 1 and g, for example, 1 over x plus 1. So the composition of maybe I will call it either f or g of x. So I start with an f, which is 2, and then instead of x, I replace it with the g of x, which is 1 over x plus 1, and then plus 1. But for a g of f of x, so I start with the g function, which is 1 over x plus 1, but instead of x, I'm going to replace it by 2x plus 1, which I could simplify it to 1 over 2x plus 2. So this is composition of function, f of g and g of x. So as you see, they're not always the same. F of g is not necessarily equal to g of x. When they are equal, we call them, the function has an inverse. So for example, the inverse of functions, as you've seen in parallel algebra, f of x, for example, is e to the x, and f inverse is ln x. And why is that? It's the inverse because if I do f of the inverse of x, I get, let's see, f, I call it e to the x, and then instead of x, I'm going to replace it of ln x. And e with the ln, it gives me just x, which is the identity. Also, an inverse of x of f, I start with the inverse, and in my example, I call the inverse ln. So ln of e to the x, this is just x. And therefore, this is the identity that we're talking about. So if f of g of f inverse and f inverse of f equal to identity, therefore the two functions are inverses of each other. So let's see this example here. Now the question, find the inverse of the following function. So for the function to have an inverse, it should be one-to-one function. So this function, as you see, we've seen it from the example above, this is one-to-one function, and therefore the inverse is very simple. The x become y and the y become x. Or the become q1, r2, p3. So this is the inverse of the f, this example f. And for this one here, so h inverse, so what should we do? We're going to do y minus 1 and then x minus 1. Let's see an example. H of 2, 3, that is 3 plus 1 is 4, and x plus 1, which is 2 plus 1 is 3. Now, what is the h inverse of 4, 3? Would that get me back to 2, 3? Let's see. If I take the y, which is 3, minus 1, and then as I said, x minus 1, which is 4 minus 1, that will give me 2, 3, which is the input that I started with. I hope this is helpful.